Hi everyone, it's Miss Carson.
And Miss Hannah.
And today we're going to talk about parallel and perpendicular lines. So at the top of your paper, you have three formulas that you'll need. You'll need your slope-intercept form, point-slope form, and your slope formula. So the difference between parallel and perpendicular lines. Parallel lines are two lines that never touch. They always have the same slope, and they have different y-intercepts. Those are the two requirements for parallel lines. So if we did a quick sketch here, and I drew this line, and I drew this line, notice that they have two different y-intercepts. And if I said the slope of this line was 3/4, then the slope of this line would have to be 3/4. Parallel lines have the same slope and different y-intercepts. Oh my God. Okay, so perpendicular lines, they are two lines that intersect at a right angle, which is 90 degrees, and their slopes are always opposite reciprocals. So what that means is if we draw a quick sketch, if this line comes up like this, its perpendicular line would come down and make a 90-degree angle there. So they can have the same y-intercept, they can have different y-intercepts, it doesn't matter. What matters is their slope. If this line has a slope of 5/2, then this line would have to have a slope of -2/5. Notice how one line is positive, one line is negative. That's the opposite, positive, negative. And then reciprocal means the numbers flip. So for example, if I give you a slope of -3, its perpendicular slope, well, if it was negative, then this one has to be positive. If it's 3/1, then its reciprocal is 1/3. If I give you a slope of 1/2, then its perpendicular slope would be, it was positive, so now it's negative. It was 1/2, so now it's 2/1. Okay, so now let's go ahead and look at a few problems. The first example says, write the equation of a line parallel to y equals 1/4 x plus 1 with a y-intercept of 6. So if the line is parallel, then I look at this line here. The slope out of that line is 1/4. If it's parallel, that means that I have to have the same slope. So my new slope is still 1/4. Well, now I need an equation of a line with a slope of 1/4 and a y-intercept of 6. That's my B. So if I have a slope and a y-intercept, then I could use slope-intercept form. And my final answer would be y equals 1/4 x plus 6. This line is parallel to this line. They have the same slopes and different y-intercepts.
So if we look at example 2, it says to write the equation of a line perpendicular to the given equation with a y-intercept of -3. So the key word here was perpendicular. And then we know our y-intercept is -3. So just like we did in the last problem, we need to identify our slope, our given slope from this equation. And we know that that is 5/3. When we're working with perpendicular though, we need to find our slope has got to be the opposite reciprocal. So that means if my given slope was positive, my new slope has to be negative. And then I'm going to flip my numbers, so it needs to be 3/5. So then we have our new slope, and we know our y-intercept is -3. So we can go and plug this in to y equals mx plus b. So our new m is -3/5. And our y-intercept was -3. So this line is perpendicular to this line because our slopes are opposite reciprocal. And it doesn't really matter about our y-intercept. There we go. 2 problems down.
4 more to go.
When did they stop listening?
Or 6 more to go. I don't know.
Is it still recording?
So, problem 3 says write the equation of a line that is perpendicular, in a highlighter, perpendicular to y equals negative 4x plus 1 that passes through the point 8, 5. So, if it's perpendicular, we know the slope has to be opposite reciprocal. And in our given equation, the slope is negative 4. So that means our perpendicular slope, if it's negative, it's now positive. If it was 4 over 1, it is now 1 over 4. So we have a slope, and on this problem, we have a slope and a point. So we can't use slope-intercept form. We have to use point-slope form, which is y minus y1 equals m, x minus x1. And we know that we only put our numbers in those 3 places. So y minus 5 equals 1/4 x minus 8. We can distribute. Y minus 5 equals 1/4 x minus 2, because 1/4 of 8 is 2. If I add 5, we get y equals 1/4 x plus 3. And this is our final answer. This is an equation of a line that goes through the point 8, 5 and is perpendicular to the given line because its slope originally was negative 4 and now our slope is 1/4.
So in example 4, it says to write the equation of a line parallel to y equals 6x plus 2, and it passes through the point 1, negative 3. So we know it's parallel, so we need to pull out our slope from our given equation, which our slope here is 6. And then our new slope, parallel, that means same slope, so we can use the slope of 6. But then, like Mrs. Carson said, we're given a slope and a point. So we need to plug that into our point slope formula. So we're going to replace y1 with 1. Our slope is 6. And x1. Oh, guys, hello. Silly me. I mixed up my x and my y. We know y1 is negative 3. And our x is 1. When we have minus a negative, we know that's the same as addition, y plus 3. There we go. So now we can go and distribute. Our last step would be to subtract the 3. And so now y is by itself. We have solved our problem. So here is our answer. And this point, or this equation, is parallel because it has the same slope as our given equation, and it passes through the line 1, negative 3.
Okay, problem 5 says write the equation of a line that is parallel to 3, negative 7, and 9, negative 5. So that's the first line. I need a line that's parallel to that line that goes through the point 6, negative 4. So the first thing we should do is if we have 2 points, we need to find the slope of that. And your slope formula was y2 minus y1 over x2 minus x1. And you had x1, y1, x2, y2. So if I plug it in, y2 is negative 5 minus y1 is negative 7 over x2 is 9 minus x1 is 3. And we know 2 negatives make a positive. Negative 5 plus 7 is 2. 9 minus 3 is 6. 2 over 6 reduces to 1 over 3. So that is our slope. since we need a parallel slope, if our original slope was 1/3, then our parallel one, we have the same slope, so we get to keep the slope of 1/3. And now I need an equation that has a slope of 1/3 and goes through the point 6, -4. So we have a point and a slope. Y minus y1 equals m, x minus x1. So we have y minus -4 equals 1/3 x minus 6. We know two negatives become a positive. Now I can distribute, and I'm going to move this back up here. We have y plus 4 equals 1/3 x, and 1/3 times -6 is -2. When I subtract 4, I get y equals 1/3 x minus 6. My original slope was 1/3. In this equation, I have a slope of 1/3, but now my final answer has a slope of 1/3, and it passes through the point 6, -4, with a y-intercept of -6. I'm going to go ahead and erase this so we can do problem number 6, and we have enough room for that.
All right, here in example 6, it says to write the equation on the line perpendicular to -2, 8, and 0, 7, where the new line passes through the point 9, 2. So we first need to go and find what our slope is. So we've got x1, y1, x2, y2. So we're going to fill this in to our yum table, our slope formula. So that means we've got y2, which is 7, minus y1, which is 8, over x2, which is 0, minus x1, which is -2. We know when we have two negatives that becomes positive. And we know 7 minus 8 gives us -1, and 0 plus 2 is 2. So we have a slope of -1/2. Here we're looking for perpendicular, so we need to know what is our perpendicular slope. Well, if this slope that we found was negative, our new slope has to be positive, and we're going to flip our numbers so it will be 2 over 1. Or we can use just 2. So if I go to plug this in, I have my point, and I have, here's my point, and I have my new slope of 2, I can plug that into the point slope formula. So we know that y1 is 9, so y minus 9. Oh my gosh, guys, what is my deal today? Y minus 2. Maybe I need to label my point x and y. And my slope of 2, x minus x1, which is 9. So I'm going to distribute 2x minus 18. Then I'm going to add my 2. Y equals 2x minus 16. So this would be my equation, my perpendicular equation. Because I have a slope of 2, and that is opposite reciprocal to the given slope of -1 over 2.
All right, example 7 says write the equation of a line parallel to -2x minus 3y equals -6 and passes through the point -6, 0. So we know that it's parallel. We know parallel lines have the same slope. So if I need the slope that's parallel to this equation, I need to take my equation -2x minus 3y equals -6, and I need to find the slope of that. The only way to find the slope out of that equation is to put it into slope-intercept form. So we need to get this y all by itself. So if I have a minus 2x, I'm going to add 2x to the other side. When I do that, I have negative 3y on this side. Remember, that's a negative there, so I need to make sure it stays there. On the right side, I have a negative 6 and a positive 2x. Well, one has an x, one doesn't, so I just have to write it out in a list. I can't combine those terms because they're not like terms. So the last step I need to remember is that this is negative 3 times y, and what are those times? Division. So I'm going to come through here and divide everything by negative 3. When I do that, I get y equals negative 2/3 x plus 2. So out of this equation, my slope is negative 2/3. Okay? So I'm going to go ahead and erase that part. I know my slope was negative 2/3 from the given equation. So now I need a line parallel to that. So I would keep this slope the same, but now it also has to go through the point negative 6, 0. So if I have a point and a slope, I have to plug it into point slope form. So y minus 0 equals negative 2/3 x minus negative 6. Two negatives, I have to switch to a positive so I don't make careless mistakes. Now I can go ahead and distribute. Negative 2/3 times x is negative 2/3 x. Negative 2 times 6 is negative 12. And then when I divide that by 3, I have negative 4. Well, if I add 0 to that, I still get y equals negative 2/3 x minus 4. So this is parallel to this equation. They have the same slope, negative 2/3, but they should have different y-intercepts.
Okay. So if we look over here at example 8, it's asking for a perpendicular line. It gives us the equation, but we need to rearrange it. So if I've got 2x plus 5y equals negative 10, first step is to move the x. So I'm going to subtract 2x. I'm left with 5y equals, I cannot put negative 10 and negative 2x together because they are not like terms. So I'm going to just write them out in a list. Then last, like Ms. Carson said, when you have the number next to a letter that means they're multiplied together. So I'm going to divide them apart. So I'm left with y equals negative 2 over 5 cannot reduce, so I'm going to leave it as negative 2 over 5x. And negative 10 divided by 5 gives me a negative 2. So the part that we need is the slope. We always know that's found right in front of x. So our slope is negative 2 over 5. So I'm going to write my slope over here, and then I'm going to erase my board. So we know we're looking for a perpendicular line, so that means our slope has to be opposite reciprocal. So if it was negative, it's now positive. If it was 2 over 5, it's now going to be 5 over 2. So I have my slope and my point. I'm going to label it so I don't mess it up this time. So I have my point and my slope, so I'm going to plug that into my formula. So y minus 3 equals the slope of 5 over 2, x minus 4. So my first step is to distribute. So 5 over 2 times x is 5 over 2x. 5 times negative 4 is a negative 20. When you divide that by 2, you're left with negative 10. My last step is to add this 3 over, and when I do, I'm left with a negative 7. So here is this equation that's perpendicular to the given. We have opposite reciprocal slopes, 5 over 2 and negative 2 over 5. And it runs through the point board 3.
So we hope you guys enjoyed watching all about parallel and perpendicular lines. The only thing you really need to remember is that parallel lines have the same slope and different y-intercepts, and perpendicular lines have to have opposite reciprocal slopes. You need to figure out what your slope is to begin with, and then take your new point and write the equation of the line. I hope you enjoyed it. We'll see you in class.
See you there.